Hello viewers, this video lecture is for the subject Theory of Computation and we are going to see the topic Turing Machine examples from the 4th unit. And the objectives are to understand the features of Turing Machine, to design a Turing Machine for a given language. First of all, let us see the definition and the features of Turing Machine. A Turing machine is a mathematical model of computation that defines an abstract machine that manipulates the set of symbols on a strip of tape according to the table of rules. Turing machine is an automation model which is used to design a language. And regarding the structure, the Turing machine consists of a tape, input tape of size infinite length size, on which this tape is used to store the input symbols. The finite control of the machine will perform the read and write operations on the tape. The tape consists of infinite number of cells on which each cell either contains the input symbol or a special blank symbol. The input symbol will be filled in the tape. All the remaining cells will be filled by the blank symbols. Also, the finite control consists of the head pointer. The head pointer will point to the cell currently being read, and it can, after reading one symbol from the current cell pointed by the head pointer will move to the next cell either in the right direction or left direction. Now we can see the problem. So we will have the problem in this manner. Design a Turing machine to accept the language. So in our problem we are having the language 0 power n, 1 power n, and n should be greater than or equal to 1. For this problem we can have the solution, that is, we have to cancel out every 1 for every 0. At last, since these languages consist of equal number of zeros and equal number of ones, at last, if no zeros and ones are left out, we can say the string is accepted. Let us take the example string for n equal to 3 value. Our string will be w equal to 000111. Let us have the example automation for the string. So initially this string will be stored onto our input tape, and all the remaining cells will have the blank symbols, and initially this will be our tape structure. So at first our head pointer will point to the first 0 on the leftmost end. Now let us use two variables to replace our 0 and 1. Let us use x to replace 0 and y to replace 1. So now we can see the sequence of operations will happen onto the tape to end for the final state, to reach the final state. Now first of all, initially the head pointer will point to the first leftmost 0. And replace 0 by x and the head pointer. After replacing the first 0 by x, it will move towards the right direction until 1 has been reached. When 1 is reached, it will replace the 1 with y and move towards left. While moving left, zeros and ones will be encountered, but the head pointer will skip all the zeros and ones and continue moving to the left until x is encountered. When the head pointer finds x, it will turn right and replace the next 0 after x and proceed moving towards right. While moving right, the zeros and y's will get encountered, and the head pointer will skip all the intermediate zeros and y's and continue moving until a 1 is encountered. Now replace the 1 with y and proceeds towards left. When y is encountered after x, then move towards right to see whether a blank symbol is there after y. If yes, move to the accepting state. That is, the case is the head pointer will move to the left and the right direction in the zigzag fashion to replace all the zeros into x, all the 1 into y, and finally, if the head pointer is able to find blank symbol after y, that means if blank symbol is available after y means all the symbols gets replaced. So at that stage the system will move to the final state, and the given input string will be accepted. Now we can see the tape structure for each and every step. Initially the head pointer will be pointing to the first 0, it will be replaced into x, and the head pointer will moving to the rightmost right direction until it encounters the first leftmost one. When it encounters the leftmost one, it will be replaced into 1, it will be replaced into y, then the head pointer will move towards left. When the head pointer identifies when it moves towards left, it will skip all the zeros. When it finds x, the head pointer turns right and the 0 after x will be replaced into x. Then it will turns right, goes on to the right direction to check for the leftmost one. The leftmost one will be replaced into y. Then the head pointer will go to the right direction and the leftmost 0 will be replaced. So finally, along the right direction, if blank symbol is found after y, then the system will go to the accepting state. That is, the string will be accepted and the system will go to the final state. Now we can define all the states of the problem. Q0 is the state where the first 0 will be replaced by x and system will move to Q1. Q1 is the state where the Turing machine skip all the zeros and y's in the way and to replace 1 by when first leftmost 1 is replaced by y, the Turing machine will be changing to the new state Q2. From Q2, the head pointer will move towards left. In the path, it will skip y's and zeros until the leftmost x is found. If found, it will move to the right direction, right on position, and at that situation we will say the state is Q3. Q3 is the state where y has been found after x. When all the x were replaced, we may found y after x in the state Q0. So move right skipping all the y's. If a blank symbol is there after y, move to the accepting state Q4. So we can write all those operations as the state transition functions, and we can represent the state transitions with the help of transition table. Now in the transition table we can have the column wise, we can have all the symbols in the column wise manner, like we have to include the blank symbol also. So we have to include the original symbol 0, 1, we have to include the replacement symbols x and y. Along with that we have to include the capital letter B for blank symbol. In the row wise, in the left hand side we have to list out all the states from Q0 to Q1, Q4. Inside the cells for the corresponding states and the corresponding symbols, we have to mention the state transitions. For example, when 0 is applied to Q0, system is moving to Q1 and the 0 will be replaced into the new symbol x, and the next the direction of movement is R. And otherwise we can, so in this manner we have to fill up the table. And we can tell another example. If the input symbol is y during the state Q1, the system remains in the same state Q1 and the symbol will be remains the same as y and the direction of movement is R. Now when the input symbol is y and the current state is q0, the same symbol will be maintained, that is y, and next the direction of the movement is r. And when blank is applied to q3, that is when the input symbol is blank and when the current state is q3, now the new state will be q4, the blank symbol will be same as blank symbol, and next the direction is right. So in this manner we have to mention all the state transitions in the transition table. Also we can draw the transition diagram for the same situations. We can have q0, q1, q2, q3, q4 is the final state. We have to put the label on the edges. In the label we have to mention the input symbol and the replaced symbol, and the third parameter is the direction of movement. Here we can mention either R for right direction, L for left direction. The same operations that we have mentioned in the transition table can also be mentioned as the label of the edges. For example, we can say when the input symbol is 0, when the current state is q0, the 0 will be replaced by x. Next, the direction of movement is r. Now, when the current symbol is q1, from the current state q1, when the symbol is 0, the 0 will not be replaced. 0 will be kept unchanged and the direction is right. Also, from the state q1, if the symbol is y, y will be unchanged and the movement is to the right direction. So we can represent all these state transitions in between the states, and we can conclude it with the acceptability. So our string is accepted. So our string is reaches to the final state q4. So this is the problems we can have for the Turing machine design. So in the university questions we can have the problem design a Turing machine for the given language. Thank you all.